Well, here we are with our first video lesson about the real number system. Let's first go over some vocabulary. Whole numbers are what is called a subset of the real number system. In fact, most of these things here on the left are subsets. A subset is just a smaller set within a larger set. The larger set being the real number system, whole numbers being a subset. And as always, we denote subsets with or sets with brackets. Whole numbers include the numbers 0, 1, 2, 3, and so forth. And I'm just going to use an ellipsis to indicate that it continues counting up 4, 5, 6, etc. Because I really don't feel like listing any more than that. There is a smallest whole number, 0. There is not a largest whole number, because that would just continue on to infinity, which is not a value. The next subset within real numbers is the set of integers, also denoted with brackets. The set of integers, as I've listed them, has a ... at the beginning, meaning that that pattern would continue even before I've started with my list of -3, -2, -1, 0, 1, 2, 3. Notice my blue numbers here in the integers set is the exact same numbers as what's in the whole number set, meaning whole numbers are a subset of integers, and every whole number also counts as an integer. Moving on to the rational numbers. There are two definitions for rational number. If a number is represented in decimal form, then it either terminates or repeats if it's rational. If a number is written in fraction form, then it can be written as a ratio of integers. Let me give you a few examples. Decimal form of a rational number, 1 1/4, would be 1.25. This number terminates. There are no decimal places after the 5, unless you want to count the unused zeros. One that repeats, for example, would be something like 1 1/3, which can be written in decimal form as 1.3 with this bar over it, meaning there are repeating threes, so 1.3, 3, 3, 3, 3, etc. Written in fraction form, both of these numbers would be what I said the first time, 1 1/4 and 1 1/3. Both of those can be written as a ratio of integers if I convert them to improper fractions, which I have just now done. 5 and 4 are both integers, and now they are written as a ratio of integers, showing the number 1.25 in fraction form. Same thing with the 4/3. 4 and 3 are both integers, and so that represents a ratio of integers. Some numbers that we will work with this year cannot be written as a ratio of integers, and when written in decimal form, they do not terminate, nor do they repeat. These are called irrational numbers. The most popular irrational number that we will encounter is the number pi, which is the ratio of the circumference over the diameter of a circle. Other common ones are a number known as e, which will be used in later math classes, probably not so much ours, the golden ratio, and there are others. Most of the ones that we'll be using would be square roots of numbers, like square root of 2, square root of 3, square root of 5, etc. Notice I skipped the square root of 4 because the square root of 4 is 2, which is a whole number, making it not an irrational number. I should probably go on to mention that integers, since they can be written in decimal form or fraction form that fit our definitions for rational numbers, integers are a subset of rational numbers. All of these numbers, rational and irrational numbers, all fit under the big category of real numbers. And that's what we've been talking about as the real number system. Now the question becomes, are there other numbers besides real numbers? Well, yes, there are, but these won't be tackled until a later math class. I'm going to draw a Venn diagram to help illustrate how these sets of numbers are subsets of each other. So all of the ones that we are going to be concerned with this year are real numbers. So I'll draw a box around all of those. Everything that fits within this box is a real number. Notice I left out the others that you'll be talking about in a later math class. Now I'll draw a box around everything that is a rational number. Integers and whole numbers are all rational numbers as well. Notice that irrational numbers cannot be part of the rational number system, so they'll get their own box. And since they have their own box, I'll go ahead and include some examples of irrational numbers now. I'm also going to include some examples of rational numbers that will not fit into the integer or whole number category. And since they don't fit into the integer or whole number category, I need a box that will exclude these three numbers that I've just written as rational numbers. There. Now you can see that negative 7/3, for example, is part of a rational is considered a rational number. It's also a real number, but it's not an integer, whole number, or irrational number. Now let's list a few examples of integers, draw a box for that, and then whole numbers and a box for that. Great, so here we have a Venn diagram that shows examples of different kinds of numbers that we'll be working with this year, and which categories they fit into. Be prepared to recreate a Venn diagram of the real number system. Our first real task is to classify some numbers. They've given us a list of numbers here in this problem and ask us to tell them whether they're whole numbers, integers, or rational numbers. Well, negative 17 is negative, so it doesn't fit in the whole number system, so I'm going to say no there. Is it an integer, though? Yes, it is. And is it a rational number? Well, all integers are rational numbers, so it should fit in the rational number category as well. 0.3, is it a whole number? Well, no, it has a decimal form, so it's not a whole number. Is it an integer? No, again, it has a decimal form, so it's not an integer. But is it a rational number? Yes. 0.3 can be rewritten as 3/10, which is a ratio of integers. Or, just looking at it in its decimal form, it terminates, so it's a rational number. 8 is a whole number, which, since whole numbers are a subset of integers, must also be an integer, which is a subset of rational numbers, so it must also be rational. Square root of 2 is not a whole number, it is not an integer, and it is not a rational number. And if you check with your calculator, you will find that the decimal approximation does not repeat or terminate. Our last task is to be able to order rational numbers and try and approximate where they should fit on a number line. The number line is going to help us put them in order, actually, so first let's find out where 2.2 is. That should be approximately, I don't know, right about there or so. I'm just going to go ahead and fill in where the rest of them should be on the number line. And now that I've put them on the number line, I can figure out which order they should go in from least to greatest, by the least being the furthest on the left on the number line, the negative 1.7, all the way to the greatest being the furthest to the right on the number line, the 2.2. Here they are listed in order from least to greatest. If you struggle with putting a number on a number line, and you're not sure where, say, a fraction should go or something, or maybe they give you a square root and you're not sure where it belongs, check your calculator and find out what the decimal approximation is, and then place it on the number line. Finally, here is your first guided practice problem that I would like for you to do and have an answer to this when you come to class. This should be in your guided notes. But make sure that you attempt this and have an answer before you come to class tomorrow.